Here is some information regarding running vision programs and the computer file structure. To start a normal inspection program, you only need to turn on the vision computer. It should run automatically. If in case it doesn't run, you can click on the vision program icon or the auto start icon available on desktop. In some cases, in case you need to use a bypass program, and then you can follow those steps here. The important one is never forget to report to the supervisor once you start the bypass program. So the files regarding to the vision system are all hosted in the C data folder here. This is a normal program file, and this is the bypass file, as you can see here, for example. And there are the for each mode, there is a dedicated folder under the data folder. So inside the folder for each mode, you will find an all folder, a failed file folder, an original image folder, and we also have a folder for earlier files. Okay. Through the next 3 slides, we will talk about 3 important portions in the vision program. First is about the camera exposure, and the second is the locating methods, and then finally the measurement methods. Now let's take a look at a picture. This is a normal vision picture of a mode 1904. The shot area is here. So in order to locate the shot area and measure accurately, we have to have a clear background around this shot area. So the background is white, and also this portion is white. Take a look at another picture. This picture isn't too bad. However, this area, in this area, you can see some black dots over here, or gray dots over here. So they may interfere with the locating methods. So those dark dots may be caused by wrong direction of the LED light, or the part orientation, either tilted up or down too much. So yeah, in case, let's assume there's no problem with the LED light and no problem with the tilting direction, then we want to adjust the compensate the exposure from the vision program itself. So you can locate the exposure adjustment section here. That's just soon after LED light on. Okay, in this section. So this is for 1904. If we highlight this portion, you can see the tool here, and you can double click on this tool, and you will find the exposures for each picture is listed. So that picture was picture number 3, and then it is at 34. Then you can change 1 or 2 points. Click on OK, and then save the program, and then switch to inspection interface, and then run the program. Okay. In order to inspect a feature, we have to locate where the feature is. It is very important in locating the feature accurately and reliably. Here are the tools that we frequently use in locating methods. We'd like to go through each tool with examples. First, let's take a look at the match pattern tool. So this is an example of mode 1176 at machine 16. And this pattern match tool is used in locating where the inspected feature is. We still remember that we used this tool in our first simple example to determine whether or not it is a good part. So remember the score used at that time was 800. Now here we notice that the score is 400 only. Why there is such a difference? Because here this tool is used mainly for locating purpose, not for determining pass or fail. So therefore, we can lower down the score as long as it can find where the feature is. Here's another example of using pattern match tool to determine where the interested feature is preliminary. Shown here is a raw image of part 1877. The short area is the rib, also possibly on those three smaller ribs. So with this image, what tools we're going to use to locate the part? We may come up with the edge locating tool, which will be introduced later, because edge locating tool might be the preferred choice for in this case. However, edge locating tool may be interfered by background noise such as vacuum tubes. Therefore, we prepared an alternative method in order to prevent false rejection. So here, what we are going to use is a pattern match tool. So if we take a look at the pattern match, we can see that the template is established covering this region, this area. And here is the matched pattern here. So if we click on this template tab, we can see the template looks like this, and the original point is at the intersection of the two ribs. That's where we place. So in case we need to recreate the template, we can repeat that origin easily. And here are the setup. Here, the score is put at 400. And the rotation angle is set at plus minus 45, so pretty wide range. Let's see the score for this one. It's 888. Now, if we need to recreate this pattern, we can click on this and we'll open the window a little larger. Open up. Let's see. And now we pick up this. Let's try to establish that.
Yeah, they have their own.
Click on OK, and then we can place the origin where it should be. We can also tune the location of the origin here. Now we have recreated this template. And let's see what happens if we go through the inspection. All right, looks like it goes well, and it's passed. So in case in the real situation, you see the situation is much different, and if you have to recreate the template, you can do it in the similar way. The second tool we're going to introduce is the caliper tool. Caliper is normally used to measure the distance between 2 points. However, we find it is quite useful in locating the part preliminary. So we are still going to look at the same picture. And now let's find an alternative method of locating the part. So we'd like to know where roughly this portion is. So now we find that this post is pretty unique, easy to find feature, because this is quite black and the background is usually white, so very big difference. And now we'd like to place a caliper tool like in this way, so it will have it's actually measuring the distance from the first intersection to the last intersection, but after that, actually not here, let's see. So after that, it actually find one point here, the other point is on this line. So now we can establish a coordinate system based on the result of the caliper. So this coordinate system is based on the origin of this coordinate system is based on the first point of this caliper result. So the coordinate system is established in this way. The next tool to look at is the most frequently used tool in our locating method. It is the Find Edges tool. We still take this program as an example. We know we already established the first coordinate system based on the caliper tool results. Now let's see, we will use the edge tool to find where this left side edge is. Notice that we checked out this reference, this option to refer to a coordinate system, which is the one established from the result of the caliper. Now we look at the setup here. The edge strength is pretty low, setting at 30, and we're looking for first edge only. We can have other options, but in this case, we'll look at the first edge only. And the edge plurality, we limit that to from bright to dark, only. So the strength we talked, it's a pretty low one, because of why? Because the background is pretty good, and so therefore we can put the strength very low, and it will be easier to find, even if the difference between the background and the part is very small, it should still catch it. Also, because the picture is pretty sharp, picture quality is pretty good, so we can set the smoothing and the steepness to pretty low values like that. Also here in the limits, we will set minimum limit is minimum number of edges to be found is to be set to 1. So in that case, if there's nothing found, then it will show red. One thing we have to mention is that our search strategy, or the principle, is progressive search, which means that the result of the searching is being more and more accurate, and the later search is based on the result of the previous search. If we take a look at the same program now, we have found this intersection, and Now we establish a coordinate system at this intersection, and now starting the search of another search of the edge. This time we are going to place the search in a different direction on this edge, and we base the reference to the previous coordinate system. And here is the result found. And now we establish another new coordinate system based on the new result. Now we will do another search, which is still again on the horizontal direction, around the horizontal direction. But this time it refers to the last coordinate system, which is more accurate than the previous ones. After that, we establish another new coordinate system, and then do another search. Now it is on this edge, and it refers to the last coordinate system. Again, establish a new coordinate system, and then do another search on the same edge but different spot, but refer to the last coordinate system. And now we can establish a line of the last 2 points. And now we can establish a brand new coordinate system based on the intersection point on this edge and also the direction of this edge. So it is a point plus orientation coordinate system. And then we'll do another search on this edge to find an intersection, and another coordinate system here. And now we'll do an even more accurate, precise search to find this edge. Establish a coordinate system. And now we can place the region of interest of inspection. Refers to the last coordinate system. And then we can do a measurement for inspection. The next tool on the list is the Find a Straight Edge tool. In this example, we're going to detect if there's any shot on the top of this rib. But first we have to locate where the feature is. It is not easy to find the location of this feature directly. We have to use a progressive searching approach. So we may locate this edge first. So we want to find the location and also the orientation of this edge. So what we can use it to use the Find a Straight Edge tool. Let's try to place one there. Now you can see the gap is quite small, and the control here is automatically placed. We can unselect the auto control, and we can increase the gap first, because let's see if we increase that to 100, see what happens. All right, the gap is larger, and you can see actually multiple intersection point. For instance, you can see a point here and a point here. Okay, and also other points. And then the software form a best fit line of these intersection points. So in order to make the result more predictable, we would like to further increase the gap such that only an intersection point here and here remains. So let's see, increase that to 600. Okay, we can further increase that. You can see this search line is almost close to the edge. All right, so we'll only leave two intersection points here and here. Okay, and then take a quick look at the strength, edge strength set 70. It looks like it makes sense here. Limit, we don't have to specify any because it only need to find the location or the orientation of the edge as the preliminary search method. So we can click on OK to complete setting up this tool. Actually, in the program, it's set up like this. Okay. All right, and now a coordinate system can be established using the result of the straight line search, and this is the angle, the orientation of that line. Okay. Once that coordinate system is established, then we can search. We can search the location of this edge. Okay. Again, we are using find a straight line tool here. This time you can see the gap is quite small, right? The gap is set to 1, quite small. This is because the strength of this edge is unstable. Sometimes it is blurring, less difference between the background and the edge. Sometimes it's stronger. So we want to guarantee there are intersection points found. So we set the gap to be smaller, so there's always some points being found.
The next tool that we are going to take a look at is the Find the Circular Edge tool. Here is an example. We want to detect any shot along the circular edge of this part. First, let's do a quick location search along the vertical direction with a Find the Edge tool. And here is the intersection point found. And then at this point, we establish a coordinate system. Then refer to this coordinate system, we will use the circular edge tool. Here is the search region. We can see the reference coordinate system is this one, which is the one we have just created. And now let's take a quick look at the setups. Here is the direction. The direction of the search can either be inwards or outwards. In our case, this is inwards. Okay, the background is white, so nothing to interfere this searching direction, and the intersection point will be right on the edge, on the edge of the part. And here is the gap of our searching. Right now it's set at 2. If we adjust to lower or higher, you can see the difference. And also, let's take a look at the edge strength. So since the contrast between the part and the background is very strong, so we can set the edge strength high. And you can see that the strongest edge strength is 210, and the weaker one is also like pretty close to 100. So if we set at 50 something, it will be pretty good in catching all the edges, all the points. Now also the focus of the picture is really good. The picture is sharp, so we can set smoothing and steepness at 4 and 2, which will be pretty suitable to catch the intersection points. Here we can also set some limits to let the location result pass or fail, but we don't have to do that because this is only used for locating purpose. Now we can take a look at the radius found, like that's close to 900, so we can set up a minimum and a maximum radius if we want to determine whether pass or fail. Here's the allowed deviation. The detected deviation is quite small. We can set a deviation here, but we really don't have to do that as well. Again, the reason is because we're not really detecting short shots by the edge searching. We're just using that for locating purpose. Now, with the result from the circular edge searching, we can place an inspection region just close to the found circular edge. In order to put that to be very close, we will use a calculator. So the input of the calculator is the radius of the found circular edge. The output, one output is just there is a minus, there's a subtraction calculation. So this new result 1 is just 1 pixel different from the radius of the found edge, and the another result is 3 pixels different from this one, or 4 pixel difference from the found radius. And so the region is the region we created for the measurement is an annulus region, and let's take a look at its setup here. The center of this region is the XY coordinate of the center of the circular edge we just found, and the inner radius and outer radius are set by the calculator result here. So it is a pretty close annulus region, pretty close to the edge. And now we can measure the intensity in this region. So if we take a look at the control of the pass fail of this intensity measurement, it is like if the maximum intensity is within 0 and 254, the result will be passed. In other words, if it is measured the maximum, if the maximum intensity is measured at 255, which is a pure white, it will be failed. So if there is any short, definitely the region will have some pure white points coming up, and it will be failed. The next tool is the blob tool, which is called the detect objects tool here. In this example, we would like to find where the tab is located. We notice that there is a bright area on top of the tab. This feature can be utilized by putting a blob tool to find the location of this bright area as the preliminary location of this tab. Let's set the inspection search region like this. And now if we use the detect objects tool and set the search region to this one, and then if we take a look at each tab, the threshold is automatically set at 128, which is good. It has already detected this bright area of interest. And if we take a look at the other settings, it ignores the objects touching the border. So this is good. If we uncheck this, it will find many other bright regions. So we don't want that. And here the minimum object size is set to 10. So we have many small blobs being found as well here, which are not needed. So we can actually raise the minimum area. And also in the sort setting, it is set by scan order of the X and Y value. We can actually select by size. We can set this to be by pixel size, and then in the descend order, so we'll find the largest blob first. So now we can see the first result is this blob. Its size is 2,700 something. In order, so we can actually eliminate the smaller ones. Actually, if we set the value a little bit higher, let's see if we set that at 200, and then all the smaller ones are gone, and this one is the only result. So now let's take a look at the threshold setting to see if it is a reasonable value. If we reduce the threshold, we can find like 57 is almost the minimum we can go. Now if we go to higher, we can find 168 is the highest we can go. Otherwise, you have another larger one coming up. So 128 is pretty close to the middle. Actually, the middle one should be like 110. So we can put the threshold at 110. So we don't have to set the limits by the minimum number of objects and the maximum number of objects. We don't have to set that, and the reason is that it's not used for a pass-fail decision. It's just being used for locating purpose. So we can click on OK. All right. The last tool listed here is the region of interest. It is actually a very handy tool, and we frequently use it in our searching method. For instance, in this example, we define a region of interest first for the search region of the white blob. When we search the white blob, we cite that region of interest here. But we don't have to use the region of interest tool. Instead, we can actually define a search region directly in this blob tool. For instance, we can use the tools here to define the region of interest directly. So we can also do that. But why we still need to use the region of interest tool? So the reason is that the region of interest tool is a very handy one. It can allow us to adjust the region easily, not only by manipulating the graph, but also actually it provides a numerical method to adjust the region of interest. And furthermore, it can even allow you to cite certain variables to control this region of interest. So that's a reason. So by the way, there are different types of region of interest, and this type is the rectangular. If we want to allow rotation of the rectangular, we can use rotated rectangular. And also, if we want to define a line, we can use the line. And then we can use point to define inspection point. We can also use the annulus. We can also use the annulus to define an annulus area for the inspection. For instance, for this corner, we can use this annulus region of interest tool. Okay.